Hi, this is Kevin, and in this video I'm going to explain and demonstrate the project myself and Elly made for EGR484. Our project is a smart door monitoring and access control system. It's based off the Raspberry Pi 3 microcomputer and uses the Raspberry Pi official camera module for image capturing. Our system uses facial detection features. These features are based on the Schaaf deep learning model of facial detection, and our code is based on a tutorial by Adrian Rosbach from the website piimagesearch.com. Mr. Rosbach also wrote a tutorial on how to install the OpenCV libraries, which are required for the Pi camera to do facial detection, onto the Raspberry Pi. Again, on the piimagesearch.com, and those two tutorials served as the basis of our coding for this project. We also sought to use some of the Raspberry Pi's built-in features to make our project more useful. We've used the SSH, which stands for Secure Shell feature, to remotely log into the Pi from any computer on the network. From there we can start a VNC server, and what the VNC server does, it also allows for remote login, but it allows us to get the Pi's entire desktop virtually on any Windows or Mac machine that shares a network with it. And for that we used a program called TightVNC. The TightVNC server went on the Pi, while the TightVNC viewer goes on the computer you wish to use to manipulate the Pi. And there, for both PuTTY and TightVNC, there are many alternatives. Those are just two that were recommended in some of the tutorials we read and were the easiest to install and configure for us. So without further ado, I will show you how we do the low remote access to get into the Pi. I'm using PuTTY SSH first, and then I just put in the Pi's IP address or host name. I named our Pi 484 Pi when I set it up, so we'll use that for it to find it. Log in with your username, and then with the password. This is the password the Pi always prompts you to change when you set a new Pi up, because anybody could log in to your Pi and do whatever they wanted with it if you leave it as a default. So now we have a terminal window, which is the same as the terminal window on the Pi, and I will execute the VNC server command, which has the TightVNC program do its thing. And here we see it has made a VNC server with this name, 484 Pi:1. So I open my viewer software. It's already populated with that from a previous login, so I hit connect. And we now get a new prompt for a password that is specific to this software. And I log that in, and we now have the Pi's desktop showing up on our computer. And as you can see, there's that default warning to change your password. So we'll go ahead and close that out. Before I demonstrate how our system works, I want to show couple things here. I made these two scripts on the desktop. They're called bash scripts, and they basically take a bunch of lines of code that would have to be typed individually into the shell and execute them all in one click. And I'll just show you what this one looks like. This first line just tells the computer it's a bash script and that it should run all this stuff below it in the terminal. Next line loads our source profile. And that's important because I installed the OpenCV software into a virtual working environment. That way, when we are not using the Pi for face detection, it's not taking up any of the resources. The drawback is we have to manually boot up that working environment before we use it. So, and that needs the profile to be loaded because that's where that environment's saved. And it's named CV, so we've typed work on CV, and it makes that environment load up. Then we just do change directory a couple times until we get to the directory where our program is running. And then this is the actual execution line. Python just tells the Raspberry Pi to run this in Python Python 2. If it was Python 3, it would say Python 3 instead of just Python. Then detectfaces.py is our detectfacesvideo.py is our program file. This subtext here tells it where to find the CAF models to compare to for doing face detection. And the second set of subtext tells it the resolution the camera is going to be showing in, as well as the resolution that the models are in, so it knows how to properly compare them. And then lastly, now before we show our project, I have a webcam set up down here, and I can run you through what the hardware of our project looks like. So as you see, I'm going to zoom in a bit, but you see the Raspberry Pi here is running, and the reason it's got that big blank spot in the middle, it's still got that password warning up. I'll scroll over there and turn that off. And now you can see our full Pi desktop, but that's not very convenient for doing demonstrations, so we're going to focus on this one up here. And then for the camera, I just want to go and show you some of our hardware. Okay, let's see if it'll let me do pan tilt. There we go. Zooming in, but you see here's our Pi. And then right here is our breadboard. I'll zoom in a little closer on that and show you the individual components. Alright, this little red box right here is our solenoid. You can kind of see the locking mechanism sticking out right where the little cursor's pointing. That's controlled by an external 5-volt power supply that's connected here. And then the connection between the power supply and our solenoid is controlled by a little relay module that's here behind the red light. This red light is just a light I've added to the system, or me and Elly added to the system to show the door is locked. There's a green light next to it that's hard to see in this picture, but you'll see it when it lights up, and that'll indicate the door is unlocked. Also, if you kind of look between the two connectors here, you'll see there's a little spot down here on the breadboard. That is our buzzer module that warns us, or it doesn't warn us, it alerts us we have somebody at our door that we need to determine if we want to let in or not. And this little blue button here is left over from a previous design. Initially you had to press that button to let somebody in, but we've since changed the code so that you can just press the O key on your keyboard to turn off or to activate the solenoid, and the Q key can be pressed to kill the system. That way, if somebody's at a remote terminal that's not near the Pi, they don't have to get up and run over to this button. I mean, you don't have to hardwire buttons all over your building. It just looks for a keystroke. Now I'm going to go ahead and start up our program. It takes a few seconds to run up, so please bear with me while it loads the virtual environment. And we'll have a little window open up here that's going to show what's displaying on the PiCam. And because I'm alone here, we're going to have to be a little creative in getting face detection modules to get somebody to come in. But here we go. I'll show you how this works. You'll have to listen kind of closely for the buzzer that alerts people of our presence, or alerts us of people's presence, because it is rather quiet. But for demonstration purposes it works. If it was a real system, we would hook up like an actual doorbell or something that would notify people. So here we go. You can see we have somebody at our door, and the computer is detecting there's an 85% chance that that's a person's face. Our threshold is set to 50% chance, so if you listen closely, you can hear that little beeper going. And the reason the beeper's quiet is because we have a little delay in the signal. It just sends the signal to turn the buzzer on for 0.1 seconds, and then immediately turns it off. If we left it on, it would be a high-pitched, constant noise, but that would also stop the camera's detection. So in the just to be able to keep the camera running, we sacrifice the buzzer's volume, but if we were using like a doorbell or something where just a single signal would chime at once, that would be perfect. So now I'm going to press the O key on my keyboard, and you'll see the green light down here turn on, the red light go off, and this solenoid retract. It will stay retracted for 3 seconds to let somebody come in, and then the system will go back to doing what it's doing right now. And now you see we have let our guest in. There was a slight pause in the video. That's something that we have to maybe address in a future version. But while the door is unlocked, the video does cut off momentarily, but it's only for 3 seconds. And then the system is set to wait for the next person to come to the door. And now, just to demonstrate that it does do face detection with real people's faces, I'll go pick the camera up and let it take a look at me. I'm too far away to be able to physically let myself in, but I'll just demonstrate that once just to show you the face detection works. Actually, I can reach the Pi's keyboard from here too, so I'll show you once that it works from the Pi terminal as well. Actually, it doesn't work from the Pi terminal right now because the program's only running on my desktop. But you see the O key still works when I come back to the desktop, even though I've left the frame momentarily. And that is our project. Thank you very much for taking the time to watch this video. I hope you have a great day. Bye.